In Python, it is not unreasonable that you're going to write a program that needs to work with JSON data or TOML data or YAML data, or maybe even MessagePack data, perhaps even structured data. And there are a lot of tools out there for each. So you have the JSON built-in library, you have the TOML library for TOML, PyYAML, Pydantic. There are all sorts of MessagePack libraries as well. But what if I told you that there was one tool that can do all of those things and it prioritized speed and ease of use over anything? Well, luckily for you, such a tool exists, and it's called Messagespec. In this video, I'm going to be showing you how to encode and decode JSON, TOML, YAML, and MessageSpec data, as well as how to work with structs, and we're going to be comparing the performance against other alternatives as well. Of course, if you find the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But there is a lot to cover in this one, so let's just get on with it. So to get started with Messagespec, all you need to do is pip install it. So we could do so pip install Messagespec. The reason I put quotes there is if you want TOML and YAML functionality, you will need to install some extra packages. So we can do that using the square brackets, and we need just TOML and YAML like that. And that will install everything we need. I have everything installed, so it's just going to come up and say that. But as you can see, we have Messagespec, where is it? It's somewhere on it, 0.18.6. And then we take TOMLW 1.0 and PyYAML 6.0.1 as our dependencies. So using Messagespec is really quite easy, regardless of which standard you're using, because there's a consistent interface between the three languages. So if we do import Messagespec here, we can use messagespec.json. We also have messagespec.toml. We also have messagespec.yaml, and then we also have messagespec.MessagePack. And I'm saying the word message so much that I can barely say it anymore, so sorry about that. But these are the four standards that it supports. JSON, you've probably heard of. TOML is typically used in configuration files. YAML, much the same. MessagePack is one that I hadn't heard of until Messagespec came along. It seems to me like it's just trying to be a condensed down version of JSON. So it's a bit smaller, but it's a bit longer to encode and decode from what I've seen. We're going to be largely focusing on these three, but if you're interested in Messagepack, you can do your own research into that. So if you wanted to encode a dictionary into a JSON file, so if you want to do the equivalent of JSON.dumps, that would be messagespec, or you could do data, equals messagespec.json.encode, because we are encoding it into a JSON string. And then we can pass, say, a 1 and then B2 as our data, and I'm actually going to save this as a dictionary called D. Because that makes things a bit easier. And this data here, if I run this now, as you can see, a byte string. So this is so JSON.dumps returns it as a string, I believe. Encode interprets it as a byte string. That doesn't matter too much, but you do need to make a few changes when you're writing it into a file. You see it does a byte string of a minified JSON file, as you would expect. If you wanted to write that into a file, then you would need to do with open, and we could just say output.json WB, so write in bytes mode. That's very important. As F, and then you would just do f.write as you would otherwise, and then we can do this, wrap that in brackets, get rid of this line, run it again. We can see we have this output.json file, and this is now just, a normal JSON file as you would expect. If we wanted to then decode that, then we could do that. So if I just copy this and paste it here, and then we open it in read, I think it needs to be in bytes mode, I don't remember. And then we can simply just do messagespec.json.decode. So we're now decoding it into a dictionary, and then f.read. And then actually, if I print that to the terminal, and then do PyScript again, we could see that our data is exactly the same as we encoded it in the first place. And the good thing about this is that when I was showing you the TOML, the YAML, and the MessagePack things, they all have exactly the same interface. So if you wanted to open this, well, let's say if we wanted to output.toml, and we wanted to encode our dictionary as a TOML file, we could simply just change this to TOML, And then we have our output.toml file, and then suddenly it's in the TOML format. If we wanted to do in YAML, we could do that. And then suddenly we have this output.yaml, oh sorry, it's gone to output.toml. I didn't change that. Output.yaml, and it's a YAML file. And if we wanted to do MessagePack, and I think the file extension is typically MessagePack, we could do something like that, and it outputs into, you know, this MessagePack format, which is just a normal binary format. And that's the real beauty of Msgspec, because if you have a program that reads a configuration file and also works with APIs, which is not as far-fetched as it might sound, having one tool that can do them both with a consistent interface is really, really nice to have. It is also much faster than the built-in options as well. So I have benchmarks, and I'm going to set them going because they will take a while, and then I'm going to show you what they're doing. So we have this benchmark file here. So we load the data and we have it in, you know, text data and then just the actual data format. And then these tests are a series of tests. So we have dictionary pairs that are all processed by this function down here, which is why it's a weird format. The top one is always the Msgspec one. So we have the actual code that's run, we have the setup and then the data. And then we have the non-Msgspec equivalent, which forms the name of the test, which is why it's the second one down. It's just the way it's implemented. So we have decoding and encoding tests for JSON. We then have OR JSON as well, which is the fastest JSON encoder and decoder. We then have TOML using the third-party TOML library. We then have TOML lib and TOML again. And then for YAML, we have PyYAML with standard loaders and then the C loaders as well. And once these tests are done, as you can see, it just repeats the test down here. It will print a table that you can see here. I've gone all out for this, as you can tell. And it prints the test name in this column here, the amount of time it took this code to run in microseconds. So do keep that in mind, this is in microseconds. And this is an average taken per run. So this is not the total time it took the test to complete. This is how long, on average, one iteration took to complete. We then have how long the Msgspec equivalent took. And then we have the speed up as well over here. So in the normal JSONs, we could see that Msgspec is 2.8 times faster at loading and 7.5 times faster at dumping, but it is slower than OR JSON ever so slightly. So do keep that in mind. If you're only working with JSON, OR JSON might be the better option. We then have TOML tests. You can see actually it's the same speed as TOML lib, which is the built-in one. And you kind of get an idea how things are implemented sometimes, because looking into it, Msgspec just uses TOML lib under the hood to load. It is actually slightly slower at dumping data than TOML. So TOML is really where Msgspec falls down a little bit. It is faster than the third-party library at loading TOML data though. So potentially, but then you have TOML lib. So if you're below 3.11, it is faster. Otherwise, it's really not. The YAML, you can see that it pretty much just uses the C loader and C dumper by default, which is nice. You don't have to deal with YAML's horrible interface or PyYAML's horrible interface. The normal loaders are very slow, as you can see, 8.3 times speed up here of Msgspec. But that is because it's using the C loader by default. So you can see that individually, Msgspec doesn't necessarily have much to offer in terms of speed, but as a collective tool to handle everything, it is really nice to just have one tool that is fast at everything, because everything is quick, even if it's not the absolute fastest way to do it. It's also the API considerations as well, because PyYAML's API and PyYAML's documentation are atrocious, and Msgspec just makes it so much nicer to deal with. On top of all of that, it also has Pydantic style structs. So if we'll do all the imports we need first. So if we do from typing import annotated, then we import MessageSpec, and we do from MessageSpec import meta struct and field like that, and it's thinking I want to do pedantic there, and then we could just create a struct using the structs or by inheriting from structs. So we're going to create my favorite profile example, and then we're going to have a name, which is a string, age, which is an int, and then jobs, which is a list of string, and we can actually set that using this field to default factory equals list. So that works exactly the same as it does in data classes, exactly the same as it does in Pydantic. There's no surprises there. And if we were to just get away, it keeps thinking I want to do Pydantic code. And if I just set this up like this, so we have p.pydantic dot or equals profile, and then we can just pass in my name and then my age. And if we print p like that, we can see that it works exactly the same as a data class. This jobs has sorted itself out. It has all the string representations and everything on top of all of that. But if we then print dear p, there we go. One day I'll learn to type, I promise. We can see that it just has age, jobs, and name. It doesn't actually have that much to it. And I can't remember if data classes is this light, but you'll notice, especially compared to Pydantic, there is a lot less going on. And this becomes apparent if you want to encode or decode structs to and from JSON, TOML, YAML, or MessagePack, because there isn't anything in the actual struct to do it. So instead, if I just get rid of that, you'll need to do, we'll do profile data equals MessageSpec.json.decode, or encode, sorry, and then you pass the class to it. And then you can do that. And we can see that it's encoded in the same way as we did earlier. You could, of course, very easily, and I'm going to copy paste this in. You could, of course, do this. So you could create an encode method of your own, and then you could just say MessageSpec.json.encode self, and then just encode that, and that'll work fine. So it's not the biggest deal in the world. You could create your own base model to do that if you wanted to. Once you actually have this profile data, you can actually decode them back into these structs. So if I do p2 equals MessageSpec.json.decode profile data, and then we pass the type to profile, and this tells MessageSpec that you want to decode into a struct rather than a dictionary. If you don't do this, it will do it to a dictionary by default. And if we print p2, we can see that it's exactly the same as the original p because it's decoded it perfectly fine. What makes this more than just a data classes clone, though, is that you do actually get validators, but they work quite strangely. So this is why we have annotated up here. So say if we wanted to validate whether age was a positive integer, so it has to be, well, not negative, so 0 or greater. We could use annotated, and then we pass int, and then not field, we use meta, and then say this meta has a number of arguments that we can give. So we are using the greater than one, or GT, and we pass it 0, so we want it to be greater than 0. And what this is doing is it's using the annotated, and I don't fully understand how annotated works. It's magic as far as I can tell. But it's an annotated type integer, and then this meta type is run when the constructor is run. And then it runs this to make sure that our thing is greater than 0. So if I just comment all this out for a second, if we run that as is, we can see it still works perfectly fine. If I then change this to -1 or -1, that hasn't worked. Why has that not worked? So it hasn't worked because I've just learned something new. When I was testing this, it came up with this validation error as I was expecting, and I presumed it worked in the constructor. No, it only validates in the decoder. So we've got this profile data here, which you can see we've encoded from a normal thing as -1. If we then try and decode that back into a profile, the validator then kicks in and we get this validation error. So the validation, while it's there, is not as strong as Pydantic's. Although in MessageSpec's defense, I'm not really sure you're supposed to be using profiles like this. Of course, I have a benchmark for this as well, which just performs a very simple check between Pydantic, which has pretty much what you've seen before, and then MessageSpec. The only difference is that we pass this keyword only equals true argument to match it more up to Pydantic's general or default behavior. And then we just run the test down here, and then we print, we do some decoding with the various APIs, and then encoding with the various APIs as well. So here's the decoding here. And as you can see in our table down here, that MessageSpec is 5.7 times faster at decoding this very, very simple example. I will hasten to point that out. And 6.5 times as fast at encoding. I will put a link down in the description for MessageSpec's official benchmarks, which go into a lot more detail, especially when it comes to JSON serialization and deserialization libraries. as well as other libraries to do validation. So I think it compares Attrus, Pydantic, maybe data classes, and a few others as well. Msgspec comes out very much on top of all of those. Apparently, Msgspec JSON encoding and decoding using structs is actually quicker than OR-JSON. I haven't tested that myself, but feel free to test it out and let me know what results you get, because I'd be interested to know. Let me know whether you're thinking of converting to Msgspec from your respective libraries or not. I really like it. I think it's got a really nice use case. It's got a really nice API, and having it be quick, even though it's not the quickest out there. Well, for structs and stuff it is, but for serialization, deserialization it's not. It's super fast nonetheless, and it's just really nice to have all of that in one tool. If you want to know more about the best that Python has to offer, then make sure you check out the Python is Awesome series in the end cards, and I'll see you in the next one for whatever we do next.